Consider f of x as 1 over x squared plus 1 for x greater than 0. Show that f of x is a decreasing function. Copy and complete the table for y is equal to f of x, giving your answer correct to 4 decimal places. Using the sum of 5 rectangles, find a and b such that the integral, or the area, from between 0 and 1 is between a and b. These are called the lower and upper bound using the rectangles. Giving a and b to 3 decimal places. Give the value of the integral from 0 to 1 f of x to as great a degree of accuracy as possible. How could you obtain your answer to a greater degree of accuracy? So in order to do this question, first of all show that the function is decreasing. So if we got f of x is 1 over x squared plus 1, then first of all we rewrite that as x squared plus 1 to the minus 1. Using the chain rule, f dash of x you bring down the minus 1, put it in front, write down the bracket, x squared plus 1, reduce the power by 1, so that now makes that minus 2, and then differentiate the inside of the bracket, which makes it 2x. Rewriting this in this format, minus 2x over x squared plus 1 squared. So we had f of x was equal to that for greater than 0, and then f dash of x is going to be between minus 2x over x squared plus 1 all squared. Now x plus 1 all squared will always be positive by the fact that you're actually squaring it for x is greater than 0, and that minus 2x will be negative for the value of x greater than 0. Therefore, you're going to have like a negative divided by a positive here in the derivative, which means it's less than 0, and if the derivative is negative, then we have a decreasing function. So hence f of x is a decreasing function for x is greater than a. Right, next what we're going to do is work out the values of f of x for 0, 0.2, 0.4, 0.6, 0.8 and 1. So if you use the table function on your calculator to do this, then you're going to get that's 1. This is 0.9615. 0.4 will be 8621. 0.6 will be 7.353. And then 0.8 will be 0.6098, and then 1 will be 0.5. So if we now look at this function, so here we have the function f of x is x squared plus 1 for values of x greater than 0. Now we want to find the area between 0 and 1. So we can select these sliders to 0 and 1. This gives the lower bound. This gives the upper bound. Now, if we want to set the end number of rectangles to 5, then to do the lower bound will be those. Okay, so you will need to find this value, this value, this value, this value, and this value. So you're going to ignore the first value, and then take the second value in your table, the third value, the fourth value, the fifth value, and the sixth value in your table. We're going to ignore the first value, and this will give an estimate for the lower bound. So the lower bound will be, taking into consideration the width of the rectangle is 0.2. So just go back to this for each minute. To calculate the area of each triangle, rectangle, we do 0.2 times this height for each one. So all I need to do is 0.2 and then add up this value, the y value here, the y value here, the y value here, the y value here, and multiply the whole lot by 0.2. So that the area will be approximately equal to 0.2. They're taking this value, so we ignore the first one, and add these all up on our calculator, and that will give me approximately equal to 0.73374. So therefore, to 3 decimal places, that would be 0.734 to 3 decimal places. Now going back to this, if we click here, It'll give me the value. So to 3 decimal places I get 0.374. Now to do the upper bound, so I'll just remove that and then put the upper bound once. Okay, so what we're doing is the left edge of the rectangle is now against the function. So we will take the first value from the table and then multiply it by 0.2, the second value, and 0.2, and then so on. But we will not take the last value in the table for the upper bound. So the upper bound will be, the area will be 0.2 times 1 plus 0.9615, 0.8621, 0.7353, 0.6098. So we're not taking the last one, and that will give approximately equal to 0.83374, and to 3 decimal places that will be 0.834. So just going back to this for a minute, if we click this one here, then we can see we get the answer correct to 3 decimal places, 0.834. So I just put that back where it was. Okay, so the inequality that we want is that f of x between the area of 0 to 1 of f of x dx must be greater than 0.734, that's the lower bound, and the upper bound will be 0.834 to 3 decimal places, therefore we've got the right format. Now, if we look at these two values, we're going to get 0.7 if we round it off to 1 decimal place, or 0.8, which do not agree. So therefore we can only say that the area of f of x dx would be equal to 1 significant figure. Now to improve our degree of accuracy for this, you would have to increase the number of divisions. Okay, so, and I can show you this using this applet. So if we look at this here, and if we increase it, let's just put up every single value now. So we've got the lower, the up area, the actual area. Okay, so the actual area is that's with the lower bound, that's with the upper bound. Okay, if we increase n, okay, so the more we get. Okay, so for here, for example, we could say this is 0.8 degree of accuracy, 0.8, because they both got the same thing. So the more we get, the better the degree of accuracy. I think 0.8. Can we get to 2 decimal places? Not quite, with 50 divisions. Best we can get is 0.8 with 50 divisions. Okay, so this has been a video to show you how to work out the lower bound and upper bound of the area of a curve using rectangles. I hope you've understood, and the GeoGebra app I will put in the notes of the video. Thank you very much for watching.